Geomagic for SOLIDWORKS is a SOLIDWORKS plugin that can be used to convert 3D scan data into solid models in SOLIDWORKS. The normal 3D scanning process uses a 3D scanner like an Artec EVA or Spider to generate point cloud data. This data is then converted into a tessellated 3D solid like an STL file. When using the Artec scanners, we like to do this using Artec Studio because it has so many great options for conversions. And although it can be done in the Geomagic for SOLIDWORKS plugin, we're not going to show that in this video. We'll assume that we bring this 3D tessellated geometry as an STL file into SOLIDWORKS using the Geomagic for SOLIDWORKS plugin, and then convert it into a 3D solid that can be used normally like any other SOLIDWORKS part. We're going to show three workflows for this process. First, we'll show how to generate a fully featured parametric model with a full feature tree. Then we'll show the auto-surfacing capabilities for more complex geometry, and finally we'll look at a hybrid method that combines these two techniques for when we have a difficult geometry with maybe one or two important surfaces, like the hole on this bracket. I'll start with some scan data of a simple part, and many people might look at this and see what seems like a SOLIDWORKS part, but taking a look at the edges, we see that there are many thousands of triangular surfaces in this STL file. I need to highlight groups of these triangles, and Geomagic for SOLIDWORKS is going to try and fit sketch data and features to these triangles. First, asking for an extrusion, I'll start highlighting groups of triangles. I've got a lot of selection tools like lasso or paintbrush, but at the end of the day, I want to highlight the outside surfaces, and the program is going to fit sketch data and SOLIDWORKS features to create this geometry. Similarly, I can extract this freeform surface from the top of the part. Now I can create a new surface body or use this surface as a cut right here in the menu. My next extrusion I'm going to do is going to be cutting material away from the part. I want this next sketch to be perfectly parallel to the bottom of the part, so I can simply pick the reference plane and force that relationship. As I continue on, I can pick other extrusions or revolves, or simple geometry like cylinders, cones, and spheres to fit two bits of my scan data as I continue to build up all of the features in this part. A deviation analysis can show where my newly generated solid body is close or far away from the original scan data, like on this slot cut where the depth isn't quite right. Quick edit to the features, and that fixes that problem. Now I've got a great solid body that I can throw into an assembly or make modifications to. However, not all shapes are easy to parametrically model. For something like this frog, I might want to use the auto surface commands. I've got a few simple options, and then I simply let Geomagic for SOLIDWORKS do the work for me, fitting NURB surfaces, that's non-uniform B-splines, all around the scan data to create a single solid body. This can take a few moments, but we need to keep in mind that the computer's doing a lot of work for us right now. My new geometry appears in the SOLIDWORKS feature tree as a single dummy solid, made up of a patchwork of NURB surfaces. Now we should acknowledge that this method is not explicitly reserved for organic shapes like this. There may be mechanical parts that I want to simply scan and have the fastest path towards a solid body that I can use in SOLIDWORKS. The hybrid method combines these tool sets so that we can quickly generate a solid body but still have parametric features where we need them, like on these mounting surfaces. I've duplicated the scan data so that I can use one copy to auto surface and the other copy to make parametric features of only the areas I care about, these mounting holes. I'm using some mesh editing tools on my first copy to delete out that data, and then I'm going to use Geomagic for SOLIDWORKS to fill those holes. Now I can auto surface this body, AutoSurface generates the gross geometry for me, and I can go back to the first copy and use it to cut out these holes in a parametric way. This way I get the best of both worlds. A quick path to a completed solid body, but I can still dimension and edit the locations of these areas that I care about for mounting purposes. I also get proper cylindrical holes here, where otherwise I would have gotten kind of a NURB surface that was close to, but not exactly a cylinder. If you're interested in learning more about Geomagics for SOLIDWORKS or 3D scanning generally, please reach out to your local Trimech representative.